Hi guys, let's take a look at this question where an experiment was conducted to investigate the relationship between the frequency of light incident on a metal and the maximum kinetic energy of the emitted electrons from the surface of the metal. And they conducted this experiment using 3 different metals: potassium, zinc, and platinum. 10.1. Name the phenomenon on which this experiment is based, and that is the photoelectric effect. 10.2. Name the physical quantity that is represented by X on this graph, and that is the work function. 10.3. Which one of the 3 metals needs incident light with the largest wavelength for the emission of electrons, and give a reason for your answer. So the answer here is potassium, and the reason for this is that potassium has the lowest work function, or you could say it has the highest threshold frequency, which is then the largest wavelength. 10.4. Define the term work function in words. So the work function of a metal is the minimum energy that an electron in that metal needs to be emitted from the metal's surface, or the surface of that metal. That is the work function. Then 10.5, calculate the work function of platinum. So there we have platinum on the graph. So we're going to use our trusty little formula, which is this one right here. Again, please write down your formula. You do get a mark for it. So you'll literally get 1 mark for writing down the formula. So we have H as a constant. So we have Planck's constant right here. So you just write that down. So that's 6,63 times 10 to the power of negative 34. And then we also have the frequency of platinum, and that has been given as 1,75 times 10 to the power of 15. So you just go all the way down, and it's that one right there. And then you jot that into your calculator, and you get 1,160 times 10 to the power of negative 18 joules. Then on the other side, I'm going to do 10.5.2. 10.5.2, they want you to calculate the frequency of the incident light that will emit electrons from the surface of platinum with a maximum velocity of 5,60 times 10 to the power 5 meters per second. So which formula are we going to use? We are going to use this formula right here. All right. So we're going to write down our formula, because you do get a mark for the formula. They want maximum velocity. So you can expand the formula because you have to insert all the values, right? So Planck's constant times frequency. The work function is also Planck's constant times frequency plus kinetic energy is half mass velocity squared. So again, we have Planck's constant on our formula sheet. So we just jot that down. Our frequency is unknown. We have just calculated the work function of platinum, so we can just write that there, which is 1,160 times 10 to the power of 18. And we add half of the mass, and an electron's mass is on the formula sheet, which is 9,11 times 10 to the power of negative 31. So you just write 9,11 times 10 to the power of negative 31. And you multiply that by the velocity that was given, which is 5,60 times 10 to the power 5, and we square that. And then we do the multiplying, to have F alone, we do division, etc. And we get our frequency of the incident light to be 1,97 times 10 to the power 15 hertz. And that is it, guys. See ya.